Good morning, ladies and gentlemen. I hope you are doing fine after yesterday's party. Unfortunately, I wasn't there, so let me introduce myself firstly. I'm the founder of Octawave. I am the first architect, and I was the main architect, but now I'm the CEO. As the CEO with part of technological knowledge behind me, I would like to share with you today with my consideration about impact of modern application architecture into monolithic application, as well as changing monolithic application into modern look. So in ancient times, well, at least a long time ago, we were using assembler. Why we are not using assembler right now to create our software? We are usually not programming assembler because it's highly complicated. It requires strong knowledge about physical architecture. It requires knowledge about CPU architecture, memory architecture, as well as architecture of devices on which we are going to operate. It's inconvenient, and because it requires strong knowledge, it's susceptible for human mistakes. Instead, a few years later, we are commonly using mid and high level languages, expecting from them to have access to rich and functional libraries, to have syntax hints, to have logical verification, loop condition checks, and many, many more. But sometimes, even, we are switching to scripting languages, expecting flexibility, agile change management, platform independency, and so on. So what it mean? It means that we are looking for simplification. We are looking for simplification through choosing ready-to-use ideas algorithm. Just try to remind yourself how often you are digging over the network, searching Google, and trying to find a model or library or maybe algorithm or idea to find a solution for your problem, to find a software which fits perfectly for your current application. So we are choosing ready-to-use libraries, we are choosing ready-to-use modules, software in general. We are using universal interfaces. By universal interfaces, I mean using frameworks. And all of this is a good principle to describe monolithic application as a self-sufficient creature. Well, all of this is, it's monolithic application. Then where do all of this lead us to? Well, it lead us exactly here. Your application became all-in-one, your application became monolithic, as well as your application became slow. But it's not the worst thing. The worst thing is that your application became unpredictable. Why your application became unpredictable? Because of unexpected algorithm behavior while in stress. Do you remember? We choose ready-to-use algorithm while we dig the network. Because of unknown libraries and models, interaction and risk, if we choose to use ready-to-use libraries and include it into our software, then those models and platforms and software have to interoperate between each other. So it means usually undefined ability to scale. Just every plugin and every software you choose to include into your software expect different approach for scalability. So if you would like to scale your application, then you have to redesign your application from the scratch almost. And undefined total cost of new product and feature. Inventable maintenance breaks, yes. If you did just create new feature of your application and you want to deploy those applications on the production environment, then you have to switch off your application, your monolithic application. You have to override your files, extend your databases, switch it on, test, and run it publicly. So it's caused by monolithic application model, where all of key functionalities are embedded into single code. So what we can do about it? You might just let your app to cooperate with others. Just wait a minute. So you want me to exchange my beloved algorithms and libraries to ready-to-use services deliberately. Next step is to consider to move to ready-to-use services instead of libraries and algorithms by swapping part of our application. by well-known replacement provided with determined performance, determined availability, with elastic and fitted cost, with determined or clear interface. Well, developing new product add-on feature being away from monolithic cost will just provide us cheaper development cost. So, all right, smart guy, but what are the examples? What are the examples? So there are tons of examples in the cloud computing. So today on today's presentation, I'm going to show you 7 examples. The first one is object storage, relation databases, messaging for application. The next is real-time in-memory caching, real-time data processing, big data, and smart anycast DNS. Let's start with object storage. Well, here we can see the thread of object storage or attributes of object storage. Ton of static data stored in cloud computing remotely on demand. I'm going to show you one example of one of our current customers. He came to us around 1 year ago, and he asked us for offering for 37 servers to migrate them to the cloud. Of course, we prepared such offering, and he called us back immediately and told us that it's too expensive, it's not comparable with any other pricing on the market. So we started digging. We just started to ask him a question: what's the application architecture of his solution? And he told us that his problem is about storing millions of objects, tons of terabytes, and provide them to the customer. Well, his company is a well-known company on Polish market. He's providing free image hosting for, well, even for auctions on Allegro, for website, and many other things. So, well, we proposed him to switch his architecture and migrate all those data to object storage. And he did it. So he migrated those millions of objects, tons of terabytes to object storage, and guess what? He ended up with 4 servers instead of 37. So, and all those 4 servers were migrated to the cloud computing. However, their role is to do some kind of a resizing service. So customers of our customer is able to put image on expected size on their website. So, well, all those data are provided directly to customer browser. There is no need to pass your data across local storage, application, web server, and to the customer browser. All those data are provided directly to customer browser from object storage. This means that we have shortened data processing. If so, then it means that you have lower processing latency. As you remember, it's really important, for example, for mobile devices. Well, we have embedded ACL. Well, if you are building our own application, which are holding tons of data, and we are using well-known solution like NFS, well, G cluster, maybe AirSync, maybe something else, and then we have to build up solution which include which are able to make our data secure. We have to build a solution to provide access to our customers on a secure way. If you are using a service as object storage, then you can just pass this functionality to the service. Our application only will have to set some kind of rules for data. Those data will be available for customers. And the other thing, separating data from application processing. This is kind of really important because, well, if you're talking about scalability, there's always an option to multiply your application on many servers. If your data is stored locally, then there's no option to do that. We are using in such scenario NFS or something similar. But, well, on the large environment, it's insanity. You are going to hit the ground very soon if you choose this solution. If you store your data in object storage as a service, then all your application is processing only logic. If it is, then you are able to clone your application as many times as you need. So if you are using cloud computing infrastructure, then you have ability to clone it twice, 10, 20 times, and as much as you need. And spread traffic across those applications, because there is no single point of failure and no single point of exchanging data. All those data are usually accessible by simple REST API. And well, it's not charged by reserved capacity, it's charged by used space, So there's no need to reserve space and pay for unused space. You as the customer or developers or your customers will gonna pay only for used space. Next service are databases. We have two approaches for databases. The first one is databases as a service. It means, well, it's dedicated for developers or for SMB marketed, well, for customers who do not require ability to access directly SQL engine to make a configuration change in config files or something similar. It is the service for customer who want just run database, create logical database, create credential and pass it to the application. Now this is a simple approach and infrastructure. While cloud computing provisioning platform will take care about while scaling those databases. And the second approach is just use infrastructure as a service infrastructure as a platform to build a SQL databases cluster. And while we have additional options for such a scenario, at least smart load balancing option in container. If you deploy SQL cluster in our infrastructure, you have ability to pass connection from your application through this container with database load balancing service, and those container, this load balancer is going to pass queries with statement of modifying data only to master server and the rest to the slave server. And all those queries will be spread across as many slaves as you have. So those load balancing options will take care of selecting those queries. You do not have to change your application at all. Of course, there's an option to vertical and horizontal scalability, so you have always an option to add CPUs, add memory, or remove them to your database, and there's an option to migrate or change speed of your disks. If you are talking about block devices, which are commonly used for databases, then in a cloud computing infrastructure, you are able to change speed of your disk usually. So you can start with lowest tier, which is around 1,000 IOPS, which is similar to server equipped with 4 magnetic SAS disks. And if you are going to scale up your database, you may end up with tier 5, which is able to generate 200,000 IOPS per second for every logical volume. So it's easy to deploy, and it's charged by computing power and the used space. The third service, which I want to describe you today, is messaging. Just let me drink. I'm sorry. Apologize. Well, the messaging. If we are going to choose a modular approach for our application, then we have to provide ability to communicate with our models. Our models are usually exchanging some kind of data, and the good idea to exchange those data is by some kind of queue service. Well, of course, you may build your own queue service. However, if you are using cloud computing, there are usually such kind of services available on request. So it's persistent and secure messages storing, it simplifies communication between participants, between subscriber and the other participant. It has ability to separate application module while keeping communication between them. So this is another option to build modular application and trying to keep communication between those modules. And it's what's the charging model? What's the billing model? It's charged by message count. So as many messages you are going to put on the wall to the queue, then the billing system will count it and charge you by this message count. Another interesting service is a real-time in-memory caching. Usually we are using in-memory caching by Memcache, maybe even by Redis. And all services in real-time memory caching services available in cloud computing are usually compatible with Memcache or Redis. However, if you are going to use such kind of service in cloud computing platform, it will usually include replication option. So there's no bother, there's no need to take care about storing data stored in a cache. If you want to reload, for example, some server running cache infrastructure. It may be used as a cache for database queries result. You may know this because maybe usually you are doing this. It may be used for session handling, intensive calculation results, for database results, and so on. However, if you choose to use cloud computing infrastructure, there is no need to do some maintenance over your own Memcache or Redis implementation. The next service, which I personally like very much, is real-time processing. It can collect and process hundreds of terabytes hourly. Data can be collected from hundreds of thousands of sources immediately. What does it mean? I'm going to show you an example. Let's assume that you are running a website and, your customers are doing on your website many different things and you want to measure it. You want to measure, you need the counters to provide information about speed of downloading many elements, about speed of running, about speed of section of your application, about modules of your application. And you have tons of customers in your website. You would like to provide, or you would like to use service which is able to accumulate all those counters in real time and do some processing on it in real time to have ability to change your application behavior online. It's not a statistical system. It's going to run real time, so you are able to react or change your application or, redesign your application to run over those counters, Well, it allows us to easily write applications that process information in real time, as I told before, such as website click streams, marketing and financial information. It can be used for marketing and financial information, for operational logs, metering data, mobile devices, and so on. And the thread of the service is ability to continuously analyze data at any volume and throughput in real time. I'm not sure I'm familiar with newest Amazon AWS service, which is called Kinesis. It's the service of real-time processing, and I encourage you to have a look on it because, it's really good and fitted for many application service. Just have a look at this. The next service is big data. Well, big data, as we know, is a batch processing, so it's not real time. It can provide tons of data for our Hadoop cluster and to wait for the result. It's something different than real-time processing, but usually if you are using or you have ability to use big data processing in cloud, then you have unlimited scalability. In normal scenario, when you are going to launch Hadoop cluster, then you have to pass all the process. You have to do some specification, go to the shop, buy the servers, maintenance those servers, power it up, configure, and blah, blah, blah. And if you are going to extend the functionality of your Hadoop or extend the performance of your Hadoop cluster, then you have to do this process again. If you are using cloud computing, it's just adding, then you have ability to just add additional servers to process your data on a Hadoop. And all of this is charged by hourly, by granted space and computational power. So you have ability to just launch your Hadoop cluster for 12 hours, for example, and the next switch it off. This is my favorite service, which is really modern. It's Smart Anycast DNS. Well, as we know, Anycast DNS is, nothing unusual. It's press DNS traffic across multiple physical locations, and it has ability to, provide the answer by the location with the fastest path. This is smart. This is Anycast DNS. However, what's smart in this DNS? The smart thing is that this DNS server have ability to using our additional service, which is Octave Watch. It has ability to monitor performance of your servers. And it has ability to fail over those servers by removing server IP address from DNS zone. It has ability to do embedded round robin and response time load balancing, because if you are measuring your application, then we know how much time it consumes to provide the content to your customers. So we have abilities, so DNS have the ability to direct your customers to the side or to the servers which are able, which are operating normally or at fastest time. There is an option for mixed weight and response time load balancing. So we are able to do, for example, A/B test or pass our customer to part of our customer to new version of our website. And the smart load balancing may be also based on a JS script included in your site. Those JS scripts will collect a lot of counters, pass it to the DNS using real-time memory processing, and give it availability, well, option to direct your customers to those servers which operate well on. Using GIP, it can direct your customers to different physical locations. It's based on GIP. As well, those DNS also is using BGP for latency calculation, trying to predict fastest path for your customer. And it's charged, simply it's charged by queries count. Well, so you see how many functions of your application can be executed on the outside. Because we have a few minutes, so I'm going to give you a funny story. A few weeks ago, I had a meeting with one of Dell engineer. And we were talking about the ability to build a public cloud offering and a private cloud offering on-site in customer's data center. And he told me one interesting thing. He told me that these days it's impossible to build public cloud offering if you are going to compete with pricing on a pricing level. Not because the price of servers, RAM memory or something similar, it's because of the price of storage. In Octawave, it took almost 4 years to build our own storage. However, just try to imagine, if you are going to run thousands of virtual machines, or 10,000 or plenty, in general, virtual machine, then those virtual machines are generating IOs. Your storage will have to provide performance for those virtual machines. If you are going to buy such kind of arrays for well-known vendors like HP, 3Per, EMC, or something similar, then you are going to pay a lot of money for it. Then you will end up with a pricing on a really high level for end customers. Well, so if we are thinking about building private cloud, there are the same rules. We need the same rules as for public cloud. However, if you are thinking about private cloud, then instead of using only infrastructure as a service, we would like to have some additional services like, as I told you before, real-time processing, Hadoop clusters, real-time caching, smart DNS, and so on. It's impossible to do that using only, for example, OpenStack. Well, one may say, then you may choose OpenStack and build your infrastructure as a service, private cloud. Well, you could. But if you do, then you will end up only with a bunch of virtual machines. You can script it up. However, there is no option to have additional services out of the box. You will spend a lot of time, you need a lot of effort to create those services. So that was the second thought. So if you are thinking about building your own private or public cloud offering, then think twice. Because there's only one reason which could, which could convince us that we should do that. It's the whole situation where legal notice, maybe local authorization or local forces force you to keep your data really close around you. If you do not have such situation, there's well, almost there isn't any reason to build up your private or public cloud offering these days, because well, you will have to spend a lot of time on building them. So well, that's all for today. Thank you for your attention. I'm open for a question, and if you have, then I'm open.